Hello, my name's Tom. In this video I'm taking production quality to a new low, but for an absolutely good cause, I think. Is there any sane and reasonable person who has not at some point in their life sat down and attempted to come up with their own design for a rotary internal combustion engine? I mean, I ask you. Well, over on the Driving for Answers channel, D4A has launched into a project to create a 3D printed rotary engine. Here you go. Here's the video. It's entitled "My Oval Engine Now Fires at Will: Major Milestones for DIY Oval Rotary Engine 2.0." Totally recommend this video. Go and watch it. It's great. Yes, I'm just filming my computer screen. It's just the easiest way to do this. Okay, so this is the thing. You can see a combustion chamber and a rotary assembly that has some moving, traveling pistons. D4A calls them traveling combustion chambers, but I'm going to call them traveling pistons because in my book that's what they are. And I just want you to see this going together so you can picture in your head what the thing looks like, because I'm going to draw some pictures and comment on some things, and you need to know what I'm talking about, otherwise it just won't make any sense and be boring and you'll go and watch another video. There's a lot going for this engine in terms of it actually working one day, I reckon. And just watch this. This is 3D printed, but it's managing to generate a flame in the combustion chamber, contain it in the combustion chamber with 3D printed TPUs sealed. And so we can see it's got successful high pressure air because it's glowing. That means it's hot. That means it's high pressure and it's pushing on the piston assembly. But it's not achieving self-sustaining rotation. D4A has some suggestions as to why. So these are all really about whether there's enough pressure at the right time in the combustion chamber, and I reckon these all do need looking at, and I'd add mixture. I think you may well have the potential for more power by adjusting the mixture. None of these is hitting, and none of the comments hits what I think is probably the fundamental thing, which is friction, and that's what this video is about. So here's my super high quality rendering of the engine in a position where the flame is the flame flange has just been ignited. So this whole area is filled with high pressure gas, and it's pressing on this part of this traveling piston. And I think it's likely that it doesn't matter what pressure you have in there at all. You could have infinite pressure, and the friction would always be more than the torque that is generated by the high pressure gas in there. If I'm right, that's the fundamental problem that needs to be overcome with this engine. So let me explain why I think this may be the case. The gas in here, just to think about how it works to start, is exerting a pressure on this piston. I'm drawing lots of little arrows normal to the surface, so they're not quite parallel to each other because the surface is curved. Right, so all along there it's exerting a pressure. This is the hub over here, and so it's rotating around this point here, and these forces are, because of this traveling piston, these forces, the total net force is not centralized on the hub. The total net force is going to be something like a force from this point in that direction. Okay, so all of the components of this one is a force that's in that direction plus a little bit in that direction. This one over here is in that direction plus a little bit in that direction. It cancels the sideways. The ones in towards the middle cancel out. So the net force is basically from the center of this curved line, a little bit in, because it'll be somewhere between, if I draw a line across there, somewhere between there and there, on the center here. There you go. And that's your force. this is creating a torque. If you consider this lever arm from the center of the spindle, that is not directly towards the center of the spindle, and so it's creating a torque. It's a relatively small torque if you consider that the components of this force resolve into a small force in that direction and a large force in that direction. This, I think, is partly where the problem's coming from, because this large force is going to be a force that drives friction, and this small force is a force that drives rotation. And it doesn't matter how high the pressure is, the ratio between these forces is the same. This one's always going to be a lot larger than this one. Right, now I've turned it on its side, so we're looking, this is the rotor, this is the spindle, and I'll just hatch in. So that's the housing. Okay, so here's the spindle, and that's the rotor, and this over here is a bearing. So that frictional force, translating it from this image to this image, becomes a force that is in that direction. What does that do? That creates a torque. Given that the spindle is held firmly by the bearing over here, that creates a rotational torque this way. And what does that do? That causes a frictional force that way and that way. The rotor pressing against the top of the housing, the face of the housing up here, and the back of the housing down here. So that frictional force is, if we come back to this image here, it's somewhere around here, and somewhere around here is the center of that frictional force. And if you have a look at the lever arm that's generating the torque, it's a similar length. So if the frictional force is greater than the rotational force, it doesn't matter how much pressure you have, this is never going to turn, because the more pressure, the more friction, and you'll never overcome the frictional force. How do we know whether or not it's higher? Well, it's going to depend on the normal force exerted over here between the rotor and the housing and the coefficient of friction. I note that this arm from the bearing to the center of the rotor here is not dissimilar in length to the length of this arm, and that suggests to me that the normal force exerted here and here is quite likely to be pretty similar to the size of that force over there. So, and we know the ratio of that force to that force is quite large. You'd have to have a very small coefficient of friction along that wall and that wall for the frictional force not to prevent rotation from happening. I think this D4A, I think this is the thing you really need to be looking at. The one single most significant thing you can do, I think, is to stick another bearing over here. That way this force is supported equally on both sides, and that counters the torque, and you then lose the pressure against the two sides there and there. I reckon that might do it, but there's more you can do with lubrication, and I think that's worth thinking about as well. If you just place a bunch of oil in these cavities over here, as this thing rotates, it's just going to keep sloshing that oil around all over the place. But that oil's going to be sealed in by your seals that you've placed here, 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 and here. And now I think TPU is rubbery, and it is quite sticky. So I think these TPU seals are also creating a real drag, probably, against the side of the housing. If you have a layer of oil sloshing around in here, it's going to lubricate those TPU seals, and I think that will reduce another source of friction. That particular source of friction is constant regardless of how much pressure there is. Well, I suppose it'll be affected a bit by pressure because the pressure will be forcing it from the side, but I suspect with enough pressure you could overcome the friction from the TPU seals. But this other friction against the sides here, it doesn't matter how much pressure you have. But put some oil in here, you can reduce the friction there and there, and you can also reduce the friction on the TPU seals. Final comment on friction is just about the filament. The carbon fiber in the filament tends to result in it having quite a rough finish. There are videos on YouTube where people have looked at how to smooth the surface of their 3D prints. Might be worth looking into those. There's not a lot of moving parts, but there are some moving parts, and the traveling pistons particularly pressing against the front and back of the housing, or moving within the center part of the rotor. I can see there's potential for frictional issues there. Oil will help a lot. Smoothing the surfaces, if you can, will also help. That's all I've got. Really love your videos. Love this project. It's fantastic. All the best with it. I look forward to seeing how it turns out.